let us look at these questions. So the first one asks, in how many ways can one tile a 20 meter into 1 meter rectangular floor using two kind of tiles, one of size 1 meter into 1 meter and another of size 2 meter into 1 meter. In the second question, it is asked that in how many ways can we write 12 as the sum of only ones and twos. So here an example is given in the question. So like 12 can be written as 2 plus 2 plus 2 plus 2 plus 1 plus 1 plus 1. So in this way, and similarly like 12 can be written as like 6 twos. Okay, so 2 plus 2 plus 2 and again plus 2 plus 2 plus 2. Okay, so in how many ways can we write this 12 as the sum of only twos and ones? Okay, now we will see how we can solve these types of questions and what are the similarity between these two type of questions. Okay, so we will show if we can solve one question, this will automatically lead to solving the other, right? So first let us look at the first question, right? So suppose here it is given a tile is there, so its length is 20 meter and the breadth is 1 meter, right? So an obvious approach that one can apply is by looking at the sequence for some sample cases, like so if we consider like a floor of length 1 into 1, then obviously there is only one way to fill up this tile using this 1 cross 1 tile, right? And similarly, if we have a 2 cross 1 tile, or sorry, 2 cross 1 rectangular floor, then we can tile it using two ways. One way will be to use a complete 2 into 1 rectangular tile here, and the second way we can use two 1 into 1 tile side by side, right? So there is two ways by which you can tile this floor. Now if we have a 3 cross 1 rectangular area, then let's see how we can tile those. So like we can take a 1 cross 1 tile side by side 3 times, or we can take a 2 cross 1 tile on one side and 1 cross 1 on the other side, and the third one will exactly the reverse of this. So it will be like 1 into 1 cross tile on the left and the 2 cross 1 tile on the right. So this can be done in a total of 3 ways. Similarly, let's look at the next case where you have a 4 cross 1 floor, right? So if this is a 4 cross 1 floor, so like we can tile in, so let's see how many ways we can tile. So one way will be to use a 2 cross 1 tile here and a 2 cross 1 tile here, then we'll can have, so like 1 cross 1 tile 4 times stacked side by side. Okay, so in another case we may have a 1 into 1 tile and a 1 into 1 tile and then a 2 cross 1 tile. For the fourth case we can have the 2 into 1 2 cross 1 tile in the extreme left and then two 1 cross 1 tiles, and in the last case we can do a 2 cross 1 tile in the middle and two 1 cross 1 tile at the sides. So you can see, so a total 5 ways it can be done, right? Okay, so this can be done for a 4 cross 1 tile, it can be done in 5 ways. So two things we are seeing here. So one is that a pattern is appearing. So for one, so if there is a 1 cross 1 floor, then a 2 cross 1 floor, then a 3 cross 1 floor and 4 cross 1 floor. So first here we are getting only one option, here we are getting two options, here we are getting three options, here we are getting five options. So as you can see, so if you sum these two, you will get the next term of 3. If you sum these two, you will get the next term of 5, and so on. So what we are seeing is that it's generating a sequence, right? So another thing that I was talking about is, you can see that obviously when we are like trying to solve this problem, we are automatically getting something related to the second question, right? So here actually what you are doing, you are actually writing like, so these three as the sum of twos and ones, right? So like this case will automatically relate to writing 3 as a sum of only 1 plus 1 plus 1, and the second case, so in this second case what you can see, we are writing 3 as the sum of 2 plus 1. So automatically these two questions are kind of related. Okay, so let's see how we can like relate these two questions more formally and solve them, right? So in the first case, let us just formalize this expression. So in the first question, what it's given is that a 20 cross 1 rectangular tile is there. So instead of doing 20, so let us generalize to n cross 1 tiles, right? So a n cross 1 rectangular space is there. So this is the floor of n cross 1 tile, and let n represent the number of ways one can tile the floor using the two tiles, right? So suppose we approach the solution in this way. So in the first case, we first put a 1 cross 1 tile here, right? So obviously this space is n minus 1 times 1, right? So automatically this space can be filled using n minus 1 ways, right? According to our given taken convention, it can be filled using a n minus 1 ways. Or another disjoint case we can have, like if we use the 2 cross 1 tile here, then obviously this will be a n minus 2 cross 1 rectangular space, and obviously it can be done in a n minus 2 ways, right? So obviously what one can do is, when you are filling the n cross 1 rectangular space, you can first place a 1 cross 1 rectangular here, so 1 cross 1 tile here, and then fill the rest of the space. Or one can first put a 2 cross 1 tile here and then fill the rest of the space. Okay, so there are no more possibilities by which you can like use this single step as the initial step, right? So we can either put a 1 cross 1 tile in the first place or a 2 cross 1 tile. So the total number of ways, if it is an, then it's just the sum of these two disjoint events, right? So they are, the first one is like, it will be the number of ways of doing the n minus 1 space, and the second, for the second case, it's basically doing the rest n minus 2 space, right? So basically if we add these two, we'll get in total how many ways one can tile this floor. Similarly, if you look at the second question, so if the number of ways one can write a given number n as a sum of twos and ones only, so you can think it like this way. So if the given number is n, then what we can do, we can first write 1, then the rest n minus 1 remaining number, right? Or the number for the or for the second case, what we can do is write the number 2 first and then fill up the rest n minus 2 sum, right? Okay, so what we can, so how they are these are too similar, as you can easily see that when we divide a number in ones and twos, so automatically we can, so there can be two mutually like exhaustive cases. So one will be like to begin with 1 and another will be to begin with 2. So there cannot be any more cases. So whenever we are like disintegrating n, we can start with 1 or we can start with 2, right? So what we can do is that, so if n represents the number of ways we can disintegrate a given number n in ones and twos, it will be basically the sum of these two cases. So like this n minus 1 can be done in a n minus ways according to our notation. So, and the second one is can be done in a n minus 2 ways according to our given notation. So how we are getting an? So an is basically the number of ways these two being added up, right? So it's basically like a n minus 1 plus a n minus 2. So as you can see, the role of 1 and 2 is kind of similar. So these two does not have any numerical significance. So the value of these two numbers are insignificant. So just we're looking at the total number of ways this can be done. So one is like you are taking a 1 here, and automatically however you do this, simply you one add to this case. So suppose let us take 5. So 5 in how many ways you can do? So like we can take add, so take 1 and then 4. So like we know the number of ways 4 can be done. So 4 can be done in various number of ways. So like we are adding 1 to each of these possibility, right? So basically the number of count is not 1 plus something, it's rather the number of branches this is generating, right? So this is 4 in this case. Similarly, it is a n minus 1 in this case, and in the second case it is a n minus 2. So you get such kind of relation in both the cases, right? So these two problems are kind of similar. So once you grasp the concept of this relation, general relation a n minus 2, you can easily solve this. So as for now, you can see that this is generating a very well-known mathematical sequence called the Fibonacci sequence, right? So you are basically getting the next number by adding the previous two numbers. So easily, if you go on, you can easily find out the answer for these two cases, right? So it will be lengthy, but like the whole idea is to like give you a conceptual overview of these two questions, right? So if you ask, so if this like number is very large, like if it's not 20, it's 200, and if it's like say 12,000, then how we can do? So then you have to solve this recurrence, right? So once you solve this recurrence formula, a n is equal to a n minus 1 plus a n minus 2, using some initial conditions is there. So to be more specific, so you have to learn this. So it's how to solve this kind of recurrence relation. So with some given initial condition. So once you learn this, you will have an idea how to get a general formulation of this type of formulas, and then we can use it to like find the value for various types of it. So basically that was it. Thank you so much.